The 3-in-1 Smart Car and IoT Learning Kit from SunFounder is a hands-on, all-included electronics kit that is perfect for anyone who wants to learn how to master the Arduino. The kit comes with an Arduino, 22 different sensors and modules, breadboards, jumper wires, and everything else you need to build a bunch of fun and interesting projects. Learn about robotics by building a remote-controlled smart car that can be controlled with an infrared remote controller, or drive on its own and avoid obstacles or follow a line. Learn about the Internet of Things with a project that lets you monitor the temperature, humidity, and light level of a room from an app on your smartphone. And build a plant monitor that tracks the temperature, humidity, light intensity, and soil moisture, and displays it on your smartphone so you can keep your plants watered remotely. It's a super cool kit, and I had lots of fun building all the projects in it. So click the link in the description below to order the kit from SunFounder. Seven-segment displays are a simple and effective way to display information from the Arduino. They're ideal if your project only needs to display numbers, like the reading from a simple sensor. They're not very good at displaying letters and words. We'll learn how to display letters and words in the video on LCD displays. But now let's look at how to use a 7-segment display to display some numbers and the reading from a temperature sensor. 7-segment displays have 7 different segments, arranged in the shape of a number 8. Each segment is one LED. To display a number, the LEDs that form the number light up. So to display the number 1, these 2 LEDs would light up. Most displays actually have 8 segments. There's a small dot over here for a decimal point. That's the 8th segment. The pins for the display are on the bottom. The number of pins depends on the type of display. You can find one with single digits like this one here, or 2 digits like this one, or ones with 4 digits. The LEDs on this display are red, but you can also get them with green or blue LEDs. You can get different digit sizes too, up to about 6 inches tall. Before we set one up on the Arduino, let's look into how they work. Like I said earlier, 7-segment displays are just a set of LEDs arranged in the shape of the number 8. To display a number, all you have to do is turn on and off the right LEDs. It turns out there are actually 2 different ways to control an LED. One way is by connecting the cathode to ground, and the anode to a digital pin via a current limiting resistor. This LED is turned on by writing the pin high. Another way is by connecting the anode to 5 volts via a current limiting resistor, and connecting the cathode to a digital pin. The LED is turned on by writing the digital pin low. Likewise, there are 2 different types of 7-segment displays: common anode and common cathode. In common anode displays, the anodes from each segment LED connect to a common anode or positive terminal. The LEDs are turned on by switching the digital pins low. In common cathode displays, the cathodes from each segment LED all connect to a common cathode. The LEDs are turned on by switching the digital pins high. The segments are named following a standard convention: A through G for the digit segments, and DP for the decimal point. In the next example, I'm going to use a 7-segment display with the model number 5161AS. It's a common cathode single-digit display. If you have the same display, the pin layout looks like this. If you have another type of display, you'll need to know if it's common anode or common cathode. You'll also need to know which segment connects to which pin. The datasheet for the display will tell you that. But if you don't know the part number and you can't find the datasheet, I have a blog post that explains how to figure it out. Once you know which pins connect to each segment, you can wire it up to the Arduino. In the next examples, the LED segments are going to connect to the Arduino according to this table. If you're using a 5161 AS7 segment display, you can use this diagram to connect it to the Arduino. As you can see here, both common pins connect to ground via a 1 kilo ohm current limiting resistor. Segment A connects to pin 6, segment B connects to pin 5, C connects to pin 2, D connects to pin 3, E to pin 4, F to pin 7, G to pin 8, and the DP segment to pin 9. Okay, now let's see how to program 7-segment displays. We're going to use a library called sevseg in the following examples. The sevseg library supports single-digit and multi-digit displays. You can download it from this link. Once you have your display connected and the library installed, we can start programming it. Let's start with a simple sketch that prints numbers to the display. The first thing we have to do is include the library. So I have #include sevseg.h here. Then we create an object from the sevseg class called sevseg. In the setup section, there's some initialization we have to do to set up the display. First, we have to declare some variables that will be used to pass information to the begin function below. The first variable, num_digits, is a byte variable that sets the number of digits on your display. In this example, we're using a single-digit display, so I have this set to 1. But if you have a 2-digit display, or you're using 2 single-digit displays, you'd set this to 2. If you have a 4-digit display, set it to 4. This next line creates a byte array that defines the ground pins when using a 4-digit or multi-digit display. I'll show you what to put here when we connect a 4-digit display, but if you have a single-digit display, leave the brackets empty like this. Now we declare another byte array called segment pins. This array defines which display segment is connected to which Arduino pin. Each element of the array corresponds to the Arduino pin number a segment LED is connected to. The elements of the array are arranged with the corresponding segments going from A to G, then DP. In this case, Arduino pin 6 is connected to segment A. Arduino pin 5 is connected to segment B. Arduino pin 2 is connected to segment C, and so on. The next line declares a Boolean variable called resistors on segments. You don't need to worry about this too much, just keep it set to true. Now we declare another byte variable called hardware config. This sets the type of cathode display you're using. My display is common cathode, so I have it set equal to common_cathode. If you're using a common anode display, use common_anode. Now we have the begin function. This function initializes the display. All of the arguments passed to the function are the variables we declared up here. Hardware config is the first argument, followed by num_digits, then digit pins, segment pins, and resistors on segments. Now we have a function called setBrightness. This does what it sounds like. It sets the brightness of the display. The argument passed to it can be any number from 0 to 100. In use though, it doesn't really have much an effect on the brightness. I think the best way to make the display brighter or darker would be to change the value of your current limiting resistors. Okay, now we're down in the loop section and we're ready to print some values to the display. To print a number, use the setNumber function with the sevseg object we declared above. So here we have sevseg.setNumber. The argument you pass the function is the number or variable you want printed to the display. So putting a 4 in here will display the number 4. You can also use a variable. In the next example, we're going to print the reading from a temperature sensor on a 4-digit display. But for now, let's just print a 4. At the end of the loop section, you need to include the refresh display function. So let's upload this and check it out. Here's my display all wired up, and the number 4 is showing just as expected. This is just a single digit, and sometimes that's all you need. But with many projects, you'll want to display more than one digit. So now let's look at multi-digit displays. Multi-digit displays are pretty similar to single-digit displays. There are just a couple of differences. On a single-digit display, each segment is driven by its own pin. In displays with multiple digits, a single pin controls the same segment on all of the digits. So there's only one pin for all of the A segments, one pin for all of the B segments, and so on. For example, here's the schematic of a 5461AS common cathode 4-digit display. You can see that one pin controls all of the A segments, one pin controls all of the B segments, and so on. Multi-digit displays also have digit pins, named D1 to D4. These are the digit pins. The digit pins are the common terminals for the LED segments of each digit. Each digit has its own digit pin. By switching power to the digit pins, each digit can be turned on and off. So if I wanted to turn on all of the A segments, I would need to send 5 volts to the A pin and ground each one of these digit pins. If I only wanted to turn on the A segment in the second digit, I would send 5 volts to the A pin and ground the D2 pin. Now let's build a circuit that uses a 4-digit 7-segment display to show the reading from a thermistor. A thermistor is an analog temperature sensor. Don't worry too much about how they work right now. We're going to learn all about them in the video on measuring temperature. To set up the circuit, connect one side of a 100 kilo-ohm thermistor to 5 volts. Then connect the other side of the thermistor to a 100 kilo-ohm resistor to form a voltage divider. The resistor connects to ground, then a jumper wire connects the middle of the voltage divider to analog pin A0. If you're using the 5461AS display, you can connect the display like this. Each digit pin has its own 1 kilo-ohm current limiting resistor. If you're using a display with a different pinout, just connect it to the Arduino following this table. Keep in mind that each digit pin needs its own current limiting resistor in series with the Arduino pin. Okay, now let's see how to program this. At the top of the sketch, we include the library, just like with the single-digit example. We create an object called sevseg from the sevseg class. Then we declare some variables and constants to do the math and store the temperature readings from the thermistor. Don't worry about these for now. We're going to see what they do in the video on measuring temperature. Now in the setup section, we have to initialize the display. Since we're using a 4-digit display, we need to set num digits to 4. In the single-digit display example, we left the digit pins array empty. But now that we're using a multi-digit display, we need to enter the Arduino pins connected to the display's digit pins. The order of the elements go from digit 1 to digit 4. So here we have digit pin 1 connected to Arduino pin 10, digit pin 2 connected to Arduino pin 11, digit pin 3 connected to pin 12, and digit pin 4 connected to pin 13. Next, we define the segment pins in the segment pins array. In this sketch, I have segment pin A connected to Arduino pin 9. Segment pin B is connected to Arduino pin 2. Segment pin C is connected to Arduino pin 3, and so on, according to the table I just showed you. Resistors on segments is set to true. The display is common cathode, so I set hardware config to common_cathode. Again, if you're using a common anode display, you would set this to common_anode. Then we use the begin function to initialize the display. We pass it the hardware config, num digits, digit pins, segment pins, and resistors on segment variables. Now we're down to the loop section. This big block of code takes a reading from the thermistor and converts it to a temperature in Celsius. It stores the reading in a variable called TC. Don't worry about how this code works right now. We're going to see it again in the measuring temperature video. I just want to show you how to print the sensor readings to the display. The important thing is to have your sensor reading stored in a variable. That's how most sensor data will be stored anyway, so that's fine. To print the sensor reading, use the setNumber function with the variable that holds the sensor reading as the first argument. In this case, it's the variable TC. With multi-digit displays, you have to define where you want the decimal point. The second parameter of the setNumber function defines where the decimal point will be located. Putting a 2 here places it 2 digits to the left of the rightmost digit. With analog sensors like thermistors, the Arduino reads hundreds of temperature values every second. When those readings are updated on the display in real time, it creates an annoying flickering effect. So we need to slow down the measurements a little to make the display easier to look at. And that's the purpose of this if statement here. First, we declare a static unsigned long variable called timer and set it equal to the millis function. That'll take the current milliseconds count and store it in the timer variable. The static keyword sets the variable's value once and doesn't change it again in the program. So in all other cycles through the loop, this line will essentially be ignored. Then we get to an if statement that says, if the milliseconds function is greater than or equal to the timer variable. When the condition of this if statement is evaluated, the current milliseconds count returned by the millis function is compared to the old milliseconds count stored in the timer variable. The first time through the loop, the millis function will be a couple milliseconds greater than the count in the timer variable. So the sketch enters the if statement. The first line says timer plus equals 300. That's the compound operator for addition. So 300 milliseconds gets added to the timer variable. The setNumber function prints the TC variable to the display, with the decimal point 2 digits from the right. Then we exit the if statement, and the display is refreshed with the refresh display function. Now the sketch jumps back to the top of the loop section. The sensor is read, and the temperature value is stored in the TC variable. Since the timer variable is static, it doesn't get updated to the latest milliseconds value returned by the millis function. So this line is basically skipped over. The last time through the loop, 300 was added to the timer variable. So timer has a value of 300 plus a few milliseconds. The millis function has only increased by a few milliseconds. When we get to the if statement, timer is now larger than millis, so the if statement gets skipped. The loop keeps looping and skipping the if statement until the millis function becomes greater or equal to the timer variable. At that point, the if statement gets executed again, and the temperature's value is printed to the display again. Let's see if this works. So here's the thermistor, and here's the display. It seems to be working fine. If I grab the thermistor with my fingers, the temperature increases. In the next video, we're going to learn another way to display information visually. We're going to learn how to use LED matrices. SunFounder is my go-to source for sensors, modules, and other parts for the Arduino and Raspberry Pi. They have a huge selection of STEM, robotics, and IoT kits, and lots of useful sensors and modules. Every product has an online tutorial with wiring diagrams and example code. They also offer free shipping on all orders, with no minimum. Give them a try at www.sunfounder.com next time you need to order some parts.